Nedaudz, izstāstīšu par, mūsu, kā to nedaudz vēsturi, kāpēc mēs esam uzaicinājuši šādā pārstāvi no Čehijas, un principā, ko mēs varam priecīgi pateikt to, ka sākot ar šo gadu, lēnā garā arī mēs uzsākam viņa pārstāvniecību Latvijā, tā kā noteikti visi jautājumus būs arī speciāli zinās, kas gan par mums, gan arī tā tālāk. Ok, es pieļauju, nodošu mikrofonu jau tālāk, un tad cerams, ka mēs tiksim galā ar prezentāciju.
Okay, thank you for the invitation. Good afternoon, everybody. I'm very happy to be here today, and I would like to introduce you our solution about design and analysis of steel connections. First of all, let me introduce myself a little bit. My name is Martin Rolny. I'm from company Idea RS from the Czech Republic, and we are a software company focused on a design of members, cross-sections and details. In my part or in my presentation, I will just introduce our solution for the steel, and after me, my colleague will tell us to describe the concrete and the pre-stressing part of our solution. I would like to tell you a little bit story behind the development and the invitation of the method which we used for the connections design. In fact, we have started, let's say, 5 years ago with a question: why cannot we design connections like this that are really, let's say, real-life connections? I hope, maybe let me ask, who deal with the steel and steel connections? Does anybody do? Yeah. So I believe that maybe you know some these type of the connections, and it could be, and it is really sometimes hard to design that if you just use some code or the way, or some simplifications which usually you need to do. Yeah. So we really think about that and start with the development of a new way how to deal with that. The essential strategy or thing is which you need to take into the account is the plastic nonlinear analysis. That's the plastification and the plastic behavior of the joints. So we model joints and analyze them with this nonlinear analysis, and we checked and analyzed all plates which are in the connections for the limit of the equivalent plastic strain. Eurocode provides us a limit which should be checked, and that's these 5% of the allowed plastification in the plates. Let me describe the opportunity. We have started the development project in the cooperation with the Czech technical universities, and after some development we have find a new solution which is the general. That means that we are able to analyze and design any topology, any type of cross sections, and let's say the as you see, anchors and details which are common in the daily practice. It is simple and fast. That means that we are able to, let's say in 10 minutes, we are able to model and analyze the most common type of the connections. Here I'd like to just mention that, of course, that you would be able to model these joints with fine element analysis programs like ANSYS, Abacus, Nastran. So maybe you know that or used it, but you spend hours, maybe sometimes days, to model the connection and analyze it. And of course, any modification of the joint is really hard, and it's a not tool for a daily practice of civil engineers. And finally, it should be, and it is, comprehensive. That means that it gives us a really clear information about the behavior of the joint. On the first view, you can see what is going on in the joint. And let's say that we have developed, and we call it component-based finite element model. This method is a synergy of a component method, which is a part of the Eurocode. And this method provides us some strategy how to check the standard type of the joints, but there is a really limited list of joints which could be easily designed according to the method. And this is the weakness of this method. And we have improved that we have combined and put that together with the finite element analysis. And that brings us really the full list of the features or the ways which we can do. And that's the stress analysis, which I've already talked about. We can provide you backlink analysis of the joint, which is really important in some cases. Stiffness analysis of the joint. And the overall check. The overall check gives you really nice view about the status of the the joint, and you can see which part is critical and what you should do with the joint. Now I would like to tell you something about some important features and inventions which are inside. First of them is that we have created a new fine element solver for that plastic analysis and for the nonlinear analysis, which I already mentioned at the beginning. And we have already implemented some improvements in the mesh. Here we have taken into the account some experience from the aircraft industry, which is not so common in the civil engineering. And as you see, we are able to model the mesh independently for each plate. You can see here in that red arrows, if you mention that there's no direct connection between the meshes of the plates. Yeah, here we model or connect it by constraints, interpolation constraints, which connect these plates together. It brings us a really big advantage of simplification of the mesh, and also the clear results for the welds which connect these plates together. Next, I would like to mention the shape, or let's say the shape modeler. As you see, we are able to model any topology. There is no limitation in the number of the members, in the type of the connections, and so on. And of course, in the cross-sections types. We model each joint by the manufacturing operations. This is something near to your daily practice of the designers or civil engineers, because you don't need to model the joint, let's say, per each component like bolt or weld. You can just select the operation, for example, the stiffener or end plate, and all necessary parts are modeled and added into the model automatically. Now I would like to tell you something about the model. For example, about the bolts. So bolts in the tension we model as a springs, as a nonlinear springs, together with the contact elements, and it gives us really realistic behavior of the joint. The same strategy we used for the bolts in shear. You can maybe nicely see that on the bottom pictures, when there is a constraint connection of the bolt and the plate, and you can see that there is just the contact in the pressed part on a plate, and it gives us really nice views. For example, At the top you can see the splice plate, which was tangent, and the compressed one at the bottom. Yeah. Also, the welds are modeled like interpolation constraints. I have already mentioned. We can provide you let's say, the clear view what is happening in the weld. That means that we can calculate the intensities in the weld, and from that we can calculate the stresses. And of course, check the welds according to these stresses and according to the code formulas. When we have finished, let's say, the base part of the model, we have developed some additionals. We call it extra mile. So first of them is the design resistance of the joint. This is a nice feature which can give you the possibility of the calculation of the maximum value of the load which can be taken by the joint. And you can see that in some cases, for example, you can find that it can take only 80% of the load which you would like to do, yeah? Because after that the checks are not okay, for example, due to high plastification of the plate, or, for example, the unsatisfied checks in the bolts. As I already mentioned, we are able to calculate rotational stiffness of the joint. This is a very useful feature for the analysis of the whole structure, yeah? Because usually you calculate some 3D model with the members, and then you can take the internal forces from the joint and apply it from the node and apply it into the joint design. Yeah, but sometimes you need to take account back and know the stiffness value of the joint. Yeah, and we can calculate and provide you this value, which is important for the final analysis of the original 3D model. Then a next feature which is implemented is backlink analysis of the joint. You know, the backlink is I would say the essential design, or something what you need to take into the account when you design steel structures. But it's not so common that you analyze the backlink inside the joint. And as you see, in some cases, this could be a really critical part of a structure. For example, here, when you can see in this connecting plate, if we have really thick thin connecting plate, there could be buckling inside the joint, which is not taken in the account or in the general analysis of the structure. Here you can see some another examples of the buckling in joints. I would like to also mention the possibility, and let's call it beam interface, and that's the link of the joint analysis with other fine element analysis programs. That means that we can automatically import the geometry of the joint and the internal forces from the 3D model. Yeah? And it can save a lot of time for the designer. Here you can see overview of the applications which are already implemented. Maybe I would mention the RFEM, which is quite useful here, as I saw. So it could be really nice feature for the designers. We have also a link with the CAD programs, so we are able to import the whole geometry and the components of the joint from the advanced steel and from the Tekla structure. Let me now summarize the solution. We are bringing a tool for the designers which can really minimize the risk of the structure defects, and decrease material consumption, and especially I would mention the reduce the time spent on the design of the joints. Yeah. Our experience is, and we asked some of our customers about that, and they told us that in past, maybe 10 or 15 years ago, they have just spent 5 or 10% with the design of the connections. Yeah, but the time is changing a little bit because there are more requirements for this, and they are now spending about 30% or more time of the design with the connections. And I believe that we bring a solution how to really dramatically reduce the time with spending time with this. And of course, we provide a clear view about the results and the status of the design. Finally, let me tell you something about our achievements. We have spent a lot of time with the verification and the validation of the method. We have done this in collaboration with technical universities. We have already sold more than 500 licenses in 20 countries. Our solution is covered by a patent, and I believe that that is a nice feature that you should know. As you remember, at the beginning I asked you that we were thinking about the question why we cannot analyze these connections, and I believe, or I know that now we can say yes, we can calculate and design with our solution. Thank you for your attention. Maybe I will just ask if there are some questions, or if you are interested in something, I could ask now or maybe lately after my presentation. Thank you very much.